This is Physical Science 2, Chapter 17, Part 2 on Weather and Climate. In this portion of the video lecture, we will be discussing weather. When we talk about weather, we have to talk about atmospheric pressures. At low altitudes, meaning that you are close to sea level or close to the surface of the earth, you have very high air pressures. The higher up in altitude you go, the lower the air pressure becomes. You can think of our atmosphere like a gigantic ocean of air that sits on top of our heads. Now, luckily for us, that gigantic ocean of air does not have a lot of mass, so we're not squished to death. But it's like in a pool when you dive down at the very, very deep end of the pool. Sometimes your ears get really tight. That's because you have all of that water pressure, all of that water sitting on top of your head. It's much like that with our atmosphere, again, except we're not squished to death because the mass of air is fairly low. So low altitudes give you high air pressure, high altitudes give you low air pressure. There's lots of reasons why we have weather on the planet. We have an atmosphere. We have global wind and pressure systems as well. In the middle latitudes, which is where we live, most of the United States falls into the middle latitudes, the westerlies are our major global wind pattern. The westerlies are winds that blow from the west in middle latitudes. So if we want to look at weather patterns and we want to see what's coming our way, we look towards North and South Dakota and to the west that way, because all weather patterns will travel from the west coast to the east coast in the middle latitudes of the westerlies. Now, in the tropics, we have the opposite of the westerlies called the trade winds. So these winds blow from the east. So if you lived, for example, in Ecuador, in South America, you would look towards the east for your weather patterns to see what's coming your way. Now, there's two big reasons why we have global wind patterns. One, no matter what time of the year it is, what season it is, generally the north and the south poles are colder than areas around the equator. So we have unequal heating of the equator and the poles, and the fact that Earth rotates causes our global wind patterns. Another pattern that affects us a lot here in the United States is what's called the jet stream. The jet stream is a very fast column of air. It's very high up in the troposphere. The jet stream controls a lot of weather processes because a lot of storm systems will follow the jet stream. And how the jet stream forms is that there is a large warm air mass and a very large cold air mass. And in that gap between those two air masses, because warm air rises and cold air sinks, the jet stream is this kind of fast tunneling movement of air in between those two air masses. So in the United States, our weather patterns are influenced by the following pressure systems and global winds: the westerlies, which we have already mentioned. The subpolar lows affect the very northern part of the United States. These are pressure systems that are coming from Canada. And the subtropical highs, which are pressure systems that are coming from the southern part of the United States and Mexico. When you look at a weather map, there's a lot of symbols on a weather map, and we'll go through a lot of these symbols. You see a big red L on a weather map. That generally indicates rainfall or storms, and that is an L for low, and low stands for low pressure. When pressures are low, generally bad weather tends to happen. If you see a big blue H on a weather map, that means that the weather is actually nice. So high pressure areas will have kind of calm winds and clear skies. The Coriolis effect also plays a key role in our weather patterns as well. Airflow around high or low pressure areas. Air will rise in the center of low pressure and it will sink in the center of high pressure areas. And again, this Coriolis effect is because the Earth rotates and because we are unequally heated from pole to equator. So in taking a look at how we can determine what our weather is, we have to deal with air masses. Generally, there are 4 categories of an air mass. A cold air mass is considered polar, and a tropical air mass is considered warm. Continental air masses are considered dry, and maritime air masses are considered moist. Maritime, kind of referring to the word marine, like the ocean, so that denotes some moisture there. And where these air masses interact, we call that a weather front. So air masses, for example, in the late fall, early winter here in Minnesota, we get a lot of polar maritime types of air masses, the cold, wet ones. In the dead of winter, like January, February, where it's very bitter cold and dry, we can have a polar continental air mass. Places in Florida and Key West, Florida get a lot of tropical maritime air masses because of the warm, moist air. And places like Phoenix, Arizona, tend to get the tropical continental types of air masses because they have very warm and dry weather. So a warm front on a weather map is symbolized with the color red, and there are half circles that are used to denote a warm front, and the circles denote which direction the front is moving. So where the half circles are, that's the direction that the front is moving in. So in a warm front, warm air rises above cold air. And in a lot of cases in a warm front, you can get those low-lying stratus clouds as a result. Now, a cold front is symbolized with the color blue for cold and little half triangles, again denoting the direction of the cold front. In a cold front, cold air will push warm air up, and a lot of times in a cold front, you can get very high cumulonimbus clouds as a result. Sometimes the front is kind of either warm nor cold. We call those an occluded front. An occluded front is kind of a mix of your warm front and cold front. So we use purple for the color, and we use each of the symbols. So we use this half circles and half triangles. And a lot of times in an occluded front, a cold front kind of bowls over and overtakes a warm front. And in some cases, you can get clouds or rain. And in other cases, if that occluded front, if all of those air masses are circulating, we can get some severe weather. Which brings us to the category of severe weather. Thunderstorms, very common type of severe weather. Basically what happens in a thunderstorm is there's a lot of updrafts and downdrafts with precipitation. If there is hail in a thunderstorm, that means that the precipitation from the thundercloud has been almost kind of falls and recycles and gets blown back up into the cloud to form ice. If you've ever seen a hailstone, they're almost, in the inside, they almost look like a jawbreaker. They have several layers of ice. And that's because of the updraft and downdrafts that they receive. Downdrafts and squalls. Downdrafts are a sinking current of cold air. They're very common during thunderstorms. Squall is a very tiny localized storm. It's very short, but it can be very violent. So squalls are a series of windy gusts associated with very short storms. Squalls can occur You can be on one side of town where the squall is happening and it's raining and there's thunder and there's awful weather, and the other side of town it could be sunny and a totally nice day outside. So squalls are very, very localized. Downbursts are often associated on the outside of tornadoes. Downbursts are when cold air hits the ground very fast and kind of flows outward. Tornadoes and hurricanes are another common type of severe weather. They are similar, yet they are different. Tornadoes are very intense, and they are short-lived, and they are very localized or contained storms. We can measure the wind speed of the funnel cloud of a tornado using what's called the Fujita scale. And so the Fujita scale is rated basically from 1 to 5. 1 being a fairly small tornado, not a lot of damage, not very high wind speeds, all the way up to a 5, which would be considered very violent, very fast, and a very large storm. Most of the tornadoes in the United States happen in what we call Tornado Alley, which basically runs from around Texas up through the Middle Plains states of Oklahoma, Nebraska, Iowa, Minnesota. The southern parts of Minnesota are kind of on the very top part of Tornado Alley. So hurricanes are also circulating air, but hurricanes are a little bit different from tornadoes in a couple of ways. One, hurricanes are a tropical storm. They cover a very large area, and hurricanes can last for days. Hurricanes will basically last as long as there is enough moisture to keep them going. So hurricanes and tornadoes are both circulating air. Generally, tornadoes are going to happen in more of a landlocked type of area, and hurricanes are more coastal. This has been Physical Science 2, Chapter 17, Part 2 on Weather and Climate.